All right, everyone. Welcome to lecture 9.4. What is this about? This is still continuation of logs. Hopefully, you've worked out the problems from 9.3. If you remember, 9.3 was converting between log form and exponential form. So now we're going to talk about some properties of logs. Or actually, I won't say properties. Let's call it the rules. Rules of logarithms. And there's three rules, okay, that you need to remember. And again, why do we need to know these rules? It's so that when we solve logarithmic equations, you're going to have to apply these rules all the time. So, like I said before, there's three. The first rule is the product rule. Now, what this basically says is if I have log base b of m times n, like this, we're multiplying two different things, then we can expand it into two smaller logs via addition. Notice the base stayed the same right there, and I was able to separate this log into two different logs. So with multiplication, we expand via addition, like that. So that's the first rule. Then you also have the quotient rule. This one says if I have log base b of, and we're dividing m over n. So m and n can be anything, okay? It could be numbers, variables, whatever. Now, how do we expand this? Well, for multiplication, we added. For division, what do you think we would do? We'd probably subtract. If you thought that, then you'd be correct. Now, very important, it's log of the top, the numerator, minus the log of the bottom. The order definitely matters for the quotient rule because we're doing log of the top minus log of the bottom. 3 minus 2 is not the same thing as 2 minus 3, correct? For the product, if you mess up the order, it is okay because it's addition, but usually you want to say log of the first plus log of the second. And if you kind of notice, this is similar to the exponent rules, right? Of like variables, right? Like if we said x times x, for example, or x squared times x cubed, what did you do with those exponents? You added them, right? So we got 2 plus 3 is 5. Same thing with the quotient rule, right? That's also similar to the rules of exponents. Like if you had y to the 7th over y squared, you'd say, oh, 7 minus 2 is 5. So you get y to the 5th. And we subtract it right there when we were dividing. So very similar concept. The last rule is called the power rule. Now, what this one says is if I have log base b of, and I'm just going to say x to the mth power. So this x is being raised to the mth. What we can do is we can take that exponent and throw it right out in the front of the log expression. Like that. So you're just basically taking that and slapping it right out in the front. So these are the three rules that you just have to remember, okay? And again, they are very useful for when you solve more complicated log equations. And it's kind of like a hierarchy right here. If you notice from this side to this side, moving from the left side of the equal sign to the right side, we created more logs, correct? That's called expanding. So when we go from the left side to the right side of the equal sign, that's called expanding the logs. And then if we go from the right side of the equal sign to the left side, we're condensing because we're making one log in that case. So now what we're going to practice is we're going to practice expanding the logarithmic equation. So we're going to go from here to here. And also this kind of serves as like a hierarchy. When you're expanding logs, usually you start with the product rule first, then quotient, then power rule last, okay? And yes, you can have all three happening at once, but we'll get to that eventually. But let's just practice a few of these first before we get to the more complicated ones. So now what we'd like to do is expand the logs, or expand and simplify if possible. So let's say we have something like log base 5 of 25x, okay? And our goal here is just simply to expand it. So you just start with that hierarchy, right? We have the product rule, power rule, and quotient rule. You ask yourself, can I apply the power rule in this? I'm sorry, the product rule in this instance. Yes, because we have, this is actually 25 times x, right? If there's no order of operation between a number and a variable, that just means multiplication. So how are we going to expand this? Well, this becomes log base 5 of 25 plus log base 5 of x. Remember, with the product rule, it was log of the first term plus log of the second term, like that. So that's us expanding it. And then we want to simplify it if possible. So when we say simplify, you only do it if something nice comes out of it. Kind of like when you have to simplify radicals, right? If possible, like if you had an answer that had the square root of 9, you'd say, oh, that's equal to 3. Same concept right here with the logs. Now with this log base 5 of x, there's no way we could simplify that right there. Usually it's the ones with the numbers, right? You want to ask yourself, is this something nice right here? So log base 5 of 25, can we simplify that any further? Well, how can we do that? Well, remember from 9.3, hopefully you've gone over that. Remember, we have this right here, right? Y equals log base b of x. That was equal to b to the y equals x, right? That was an equivalent expression right there. So what if we tried that off to the side? If I take log base 5 of 25 equals y, if we convert that into exponential form, that's 5 to the y power equals 25, right? Because remember, we're just matching b with the b, y with the y, x with the x, and we get this exponential expression right here. So you would ask yourself, is y a nice number right here? Can I raise 5 to some power that will get me to 25? Yeah, super easy, right? We know y is equal to 2. So we can simplify this to something nice. Log base 5 of 25 is just simply equal to 2. But then we need to drop down the rest of the expression that we had left over. So this would be your final answer right here. Now, will this always happen? Will you always be able to reduce that log of a number, of some number, to something nice? No. Like if this was log base 7 of 25, it wouldn't be anything nice. So you just drop that down right there. So again, you only simplify it if it comes out to something nice. How do we determine if it breaks down into something nice? You need to go back to this right here, y equals log base b of x, and convert it into exponential form and see if you can work that out very easily. If you can, great, right? Then you just you rewrite it with that number that it breaks down into. If you can't simplify to something nice, you just drop it down. But this would be your final answer in this instance. So let us try this. Log of 29xy. So now we're still doing the product rule, right? Because we're multiplying 3 things right here, 29 times x times y. Now, even though when I initially wrote the rules down, I said m times n, you could be multiplying 1,000 things, or we could be dividing 1,000 things. It still works out the same way, okay? Whenever you're multiplying terms, when you expand it out, it's done via addition. So we'd have log of 29 plus log of x plus log of y, like that. Now, the next question is to simplify it further if possible. Well, we know we can't do these. What about this log of 29? Now, remember, if they don't specify a base right here. Remember, like on the calculator, I mentioned it before. If they don't specify a base, was it automatically? It's an automatic 10. So these are all 10s right here. Do you need to write these 10s in right here? No, it's just understood that it's a 10. So they don't give you anything there. It's automatically 10. So these two can't be simplified. So what we want to figure out is log base 10 of 29 something nice? How do we determine that right there? You're going to go back to these equations right here. Let's rewrite log base 10, log 10, log base 10, log base 10 of 29. Let's put that into exponential form. So remember, we're going to slap that y right here. So how are we going to write log base 10 of 29 equals y in exponential form? Just looking at this, it'd be 10 to the y power equals 29. This raised to that equals that. So now you want to ask yourself, can I raise 10 to some nice number to get me to 29? No, right? When I say nice number, I mean like a whole number or an integer, positive or negative whole number, a nice fraction. No, right? 10 to the first is 10, 10 squared is 100. So no, it is something nice. We'll just say y won't be nice. So this is your final answer right here. If you notice, we couldn't break that down to something nice. Don't always expect it to automatically be something nice like the first problem. So this is your final answer. This is as far as you can take it right there. Again, what we're doing is we are expanding, right? We're making more logs. Now let's try log base 14 of x over y. Now we're no longer multiplying. We're dividing two terms right here. So that means we're going to do the quotient rule. And remember, that just means log of the top minus log of the bottom, or log of the numerator minus log of the denominator. Very important when you're expanding and your bases are something other than 10, make sure y'all put those, right? Because if you just type in log of x minus log of y in the computer, for example, on Alex, it'll tell you you're incorrect because the base is not 14. So make sure you pay attention to that. And then we would try to simplify it if possible. But again, this is a number, this is a variable. You can't simplify that. So that's your final answer right there. Let's try natural log of e over 5. So remember, natural log is just a regular, it is a log, it's just a special log, right? With what? Do y'all remember? Who remembers? Raise your hand, right? Virtually. But remember, natural log of x is just a log with a base e, right? That's what it was. It was a unique case right here. So it is still a log. But let's go out there and try to simplify this. This still follows the properties, the three properties that I just wrote down, because it's still a log, right? So since we're dividing right here, that's natural log of e minus natural log of 5. And again, you want to simplify it further if possible. Does something nice come out of one of these right here? Natural log of 5, it is true. We could type that in to the calculator. If we did that, natural log of 5, you'll see. But that's not a nice number. We got a decimal. So if that happens, you leave it alone. This is still natural log of 5. But what is the natural log of e? If you recall from the previous section, that's a nice number. Remember, natural log of e is just 1. If you forgot that, though, you can type it in, right? Like, look, natural log of e to the first, and out pops out the 1. So that is your final answer right there. What if I had something like this? What if we're dividing multiple things, right? Like, what if we have natural log, and I'll say of 2 over x, y, like that, right? Just like with the multiplication when we had 3 things before. What if we're dividing multiple things? How would you expand that right there? Well, we're still doing the quotient rule, right? We're still dividing right here. So how does this work, right? Because you may be thinking, oh, this is product on the bottom right here. But we are still dividing, right? So how do we work this out? Well, remember, still natural log of the top minus natural log of the bottom according to the quotient rule. Now, how will we do that? Well, we're going to have the natural log of 2. And let's take care of that x component first. So we're dividing this 2 by the x, right? Remember, if we're dividing, when you expand with the log, you're going to subtract that. So we're going to have minus natural log of x. We're also dividing the y. So again, because it's the quotient rule we're dividing, we're going to subtract that right there. So anytime you have another piece in the denominator, you're going to subtract that. So if I had a z, x, y, z in the bottom, then I'll say minus natural log of z. Anything from the denominator becomes minus natural log of that. Okay. And then can we simplify this any further? Is natural log of 2 something nice? No, right? How can you test that? Go to your calculator. Natural log of 2. Oops. What do we get? A decimal. That means you leave it alone. So this is your final answer right here. All right, let's try this out. Log base 3 of the 6th root of n to the 5th. Crazy, right? Looks really bad, right? So we need to expand this right here. You may be thinking, how can we expand it? I don't see any exponents. Well, there are exponents right here. Remember, anytime you're dealing with logs and radicals, you want to convert that radical into exponential form. And they all behave the same way, right? Like if I have the square root of x to the m, and I have the n right here, like the nth root, that's the index of x to the m, then this becomes x to the m divided by n, right? That's always your numerator. The index is always your denominator. Now, how can we rewrite this? This becomes log base 3 of n to the 5 over 6. So now this is the power rule, right? Because we're not multiplying or dividing. So what do we do with the power rule? We just simply take this exponent and we throw it out in the front. So this becomes 5 over 6 log base 3 of n, like that. Can we simplify this any further? No, because again, if you have a base here and a variable, I mean a base that's a number and this is a variable, you can't do anything with that any further. So this is your final answer right here. All right, let us try one like this. So right now we have log base 5 of 1/25 times x times y cubed right here. So multiple things going on, right? We have actually 2 rules right here. What are they? Well, we're multiplying. So we have the product rule. We also have an exponent. So we also have the power rule. So we have 2 out of the 3 rules. And remember, how do we do this in terms of hierarchy? Well, when you're expanding, you do product first if it's happening, then quotient, and then power rule. So the first thing that we're going to do is we're just going to expand it via the product rule. So we have log base 5 of 1/25 plus log base 5 of x plus log base 5 of y cubed. And remember, don't forget Always the bases are 5 in this instance right here. Now, what we're going to try to do is simplify the numbers if possible. Like maybe this can be simplified. And we're also going to do the power rule right here, right? We know what this is for the power rule. Remember, the power rule just says, oh, you take that power and you throw it out in front of the respective log. Notice I didn't put a 3 here or here because that cubed was only being applied to the y, right? So be careful with that. So this last little term just becomes 3 log base 5 of y. So that's finished. Log base 5 of x. Can something else be done to further simplify that? No, because again, it's a number. The base is a number. That's a variable. So we just drop that. Now what we need to figure out is, can log base 5 of 1/25th be simplified? How can we determine that right there? So remember, what do? Let's convert that into exponential form. So we have this, right? I remember the exponential form said b to the y equals x. So this is equivalent to 5 to the y equals 1/25. Is that something nice right there? Can we raise 5 to some kind of exponent that's going to get us to 1/25? Well, we know 5 squared is 25, right? And remember from the previous lecture, I said, oh, if you go from a whole number to a fraction via exponent, that exponent's going to have to be negative. And in this case, y is going to have to be -2. Why is that the case? Well, because if I have 5 with a -2, that's 1/5 squared, right? That makes it positive, and then we wind up with 1/25. So this becomes -2 right here. That becomes your final answer, -2 plus log base 5 of x plus 3 log 5 of y. Now, what if we have log of x squared y cubed over z to the fifth power? It's a 5 right there. Now we have all 3 rules, right? You're multiplying, you're dividing, they all have exponents. How do we do it when we have all 3? Again, you follow that hierarchy, okay? So product rule comes first. Now, and then quotient and then power. But since we have both the product and the quotient together occurring in this problem, we're going to do them both at the same time. What do I mean by that right there? Well, first, we're going to take care of the numerator, and then we're going to transition to the denominator. And what I'm going to do is, let me add another term in here. I'll put z to the 5th, and then a to the, I'll say a to the 6th on the bottom, okay? So we're multiplying 2 things and dividing 2 things. How are we going to expand this? Well, first, we're going to do the numerator, meaning I'm just going to do the product rule expansion first. So log of the top, so it's going to be log of x squared plus log of y cubed. Now, when we transition to the denominator, remember we're dividing, but as far as division with the expansion of logs, you have to subtract. So I'm going to have minus log of z to the 5th. We're also dividing that a to the 6th. So I'm going to have minus log of a to the 6th, like that. So again, we added these 2 because we're multiplying the x squared times the y cubed. That's the product rule. Then when you divide, for every piece that you divide on the bottom, you're going to subtract that respective term because of the quotient rule. And then we need to finish it off with the power rule, right? The power rule says, oh, if I have an exponent up top, I'm going to drag them out to the front of their respective logs. So this is 2 log of x plus 3 log of y minus 5 log of z minus 6 log of a. And we can't simplify any of these because remember, these are all base 10s right here, and these are variables. So that's as far as you can take it. So that's how expansion works. We're creating more logs. Now we're going to go in the reverse direction. We want to condense into a single log. And then simplify if possible. So we're going in the exact opposite direction. So instead of going from here to here, we would be given something like this, and we want to get back up to here. Notice how it says condense into a single log. So usually you'll start with a bunch of logs, and your goal is to get to one log of something or a nice number if possible. So let's say we have this natural log of y plus natural log of 6. Again, our goal is to get it down to one log or a single term or single number if possible. So we're starting with this natural log of y plus natural log of 6. What does that mean right there? What was the addition associated with the properties of the logs? Well, addition was associated with the product rule. So this becomes the natural log of y times 6, right? And we could check that because remember, if we were expanding, what will we do? We do natural log of the first plus natural log of the second. But we're not going to say, oh, it's natural log of y times 6. What is y times 6? It's 6y, right? So this is natural log of 6y. So just multiply the insides if you can. This is as far as we can take it because nothing, natural log of 6 is nothing nice, right? That's a decimal right there. So that is your final answer. Now, what if we have log of base 15 of 25 plus log base 15 of 9? All right. Looking at this, well, again, we're adding, right? So adding with logs corresponds to what property with the logs? The product rule. So this says, oh, we're going to have log base 15 of 25 times 9. So let's simplify that. What is 25 times 9? This is log base 15 of 225. So now we have log of a number, base of a number of some number. Does that equal something nice? Can we simplify that right there? Remember, how do we do that? We're going to convert that into exponential form. If we have y equals log base 15 of 225, what is that equivalent to in exponential form? B to the y equals x. So it's 15 to the y equals 225. If you need to, which you should, always write this off to the side and just work it out and see what happens. Can we raise 15 to some power that will get us to 225? Yes, if y is equal to 2, right? Because 15 squared is 225. So your final answer for this particular expression is 2. So as you can see, there's two possibilities that you'll wind up with when you're condensing. You will either have one log answer or you will get a nice number. If you're simplifying or condensing these and your answer has more than one log, you did something wrong. You have not condensed all the way. Let's try this. 7 log base 5 of x plus log base 5 of y. So right here, what's going on? We have two properties going on. We have, you see the addition sign, right? That's product rule. But we also have this number out in the front. We have some term out in the front of one of the logs. That's the power rule. So when you have multiple rules, what's the hierarchy? You go in the reverse order, right? So remember how I mentioned we had the power product. No, this is we had the product, quotient, and power rule, right? When we were expanding, we went this way, expand. But when we condense, we actually go this way. So you go in the reverse order, right? Because we're just going backwards. Condense. That's condense. I wish the the whiteboard was bigger, but that's so when we condense, we do power first, if possible, then quotient, then product. So reverse order of expanding. So what do we need to do first? First, we're gonna just move this 7 back up to the next to the x, right? It's not being applied to the y because there's no 7 in front of this log. So this becomes log base 5 of x to the 7th plus log base 5 of y. So that's the power rule taken care of. There's no quotient. Do we have a product rule? Yeah, right? Because we're adding. So this becomes log base 5 of x to the 7th times y. Like that. Can't simplify this because this base is a number. These are variables. So that's as far as you can take it. But you see, if you have multiple things going on, you start with, and you're condensing, you start with the power first, then quotient, then product. All right, what if I have log base 2 of 96 minus log base 2 of 3? Okay. Now, what does subtraction correspond to? That was the quotient rule, right? So if we condense this, this is log base 2 of, I remember order matters, right? So it was always log of the top minus log of the bottom. So we're going to have 96 divided by 3. And then we can simplify 96 divided by 3, correct? That's log base 2 of 32. Now, is this something nice right here? Right? There's always a possibility it could be or it couldn't be. Well, let's check to see. How do we check that? How are we going to check that right there? Again, we're going to convert that into exponential form. So if we have log base 2 of 32 equals y, what is that equivalent to? That's 2 to the y power equals 32. Can we raise 2 to a nice number that gets us to 32? Sometimes you will be able to do this, sometimes you won't. In this case, yes. If y is equal to 5, that works out, right? Because 2 to the 5th is 32. So your final answer in this case is 5. That's your final answer. But as I keep mentioning, don't always expect your answer to, if you have log of a number equaling log of a base of a number, it's not always going to equal something nice, right? Like if this is 2 to the y equals whatever, 9, it's not going to happen, right? So you just leave your answer alone. So don't always assume, oh yeah, it's going to come out to something nice, because it won't. Now, what if we have, say, something like log, log of, I'll say this, 3 log of x plus 7 log of y minus, and I will do log of 64 minus log of, I'll say z to the, or I'll say minus 5. Let me erase some of this stuff. Give me a second. I'll say minus 5 log of z. So what in the world do we have right here? We have all three rules, right? What do we have right here? Well, we're adding, so that's product rule. We're subtracting, that means division, right? The quotient rule. We have numbers on the front of these logs, that's the power rule. So how do you do that when you are condensing? Remember, the hierarchy for condensing is you do power first, then quotient, then product. But since we have product and quotient happening together right here, we're going to do them both together. But first, both together simultaneously. But first, let's take care of the power rule, right? That just means, oh, we're gonna take these numbers, these coefficients, and slap them in front of their, or raise them up to those respective logs. So we're gonna have log of x cubed plus log of y to the 7th minus log of 64 that had no power, what had a 1, and then minus log of z to the 5th. Now we're going to go from left to right and just start or finish up the remainder of the condensing. So remember, addition, how did you condense those? You would do it by multiplication. So this is log of, now this is x cubed times y to the 7th. Why are we multiplying? Because they were separated by addition. And remember, with the subtractions, that signifies, oh, we're dividing, right? That's the quotient rule. So we're going to have divided by, since this had a minus sign, that 64 is going to go in your denominator. Since this had a minus sign, that z to the 5th will also go in your denominator. And then make sure you put the parentheses, right? Does this simplify to something nice any further? No, right? Not at all. Even if we had this expression, log of 64, that would not equal something nice, right? Because remember, what's the base if they don't give it to you? It's automatic 10. So even if you were trying to evaluate this alone, if you try to work that out, this would be, because again, if they're not specifying a base, it's 10. You would have 10 to the y equals 64. You can't raise 10 to some nice whole number integer to get you to 64. Yes, you can solve it. It would be a decimal answer. That's what's talked about in the future sections that we're getting up to. But you can't simplify that to something nice. So that would be your final answer right there. Again, we're learning all this right here because in the next section, we're going to start solving more and more complicated log problems or equations. And in order for you to solve log equations, you have to have a single log. So you're going to have to be able to condense down to a single log so that way you can solve the equation. So make sure you all work this out in preparation for the next section, okay?